to represent both TDP and the university today. I'm entering my 4th year as a Bachelor of Science, Fish and Wildlife, and GIS student. So, shall we do it? This is oh, it's not. 3 seconds! Hey. All right. So so last summer I had the opportunity to work with Rob Craig, Dick Minen, and later Sean Lackey on what we called the Kootenai Project, which was a set of orthoimages and corresponding LiDAR data commissioned by UNBC, I believe for risk assessment purposes. I worked primarily on generating the orthoimages for the project, so I'll focus on the challenges that were born out of processing such a wildly gigantic set of data. So the unique aspect of the project is the scope and the level of detail in the images. So the area covered almost 4,500 square kilometers with orthos at a 10 centimeter ground sample distance clipped to 1 to 2,500 scale tiles. And I submitted those in 1 to 20K packets. I was given 15,201 aerial images with corresponding IMU data, which were flown by plane in the summer of 2017. One set of my images were taken at a ground sample distance of 12.5 centimeters in the steep and high elevation terrain, and then the other set was at a 7.5 centimeter ground sample distance for low-lying urban areas. I also had the unique setup in that while I was working for TDP, I was physically working out of the GIS lab here on campus, so I got there are some perks with that. So I was provided with 3 machines for the job from TDP. The most powerful of which had 320 gigabytes of RAM and a 60 terabyte RAID, 196 gigs of RAM and 45 terabytes RAID on the next one. So the perks of working out of the GIS lab here is that I got to work closely with Scott Emmons for bouncing ideas and tech support, and also having the power of 17 additional lab computers if I chose to add them to the network. So, in theory, the project was simple. Just process the orthoimages in Photoscan, which is now called Metashape, quality check and make any repairs, and clip out the tiles in PCI Geomatica. For those of you who aren't familiar with Photoscan, I'll give you a quick rundown of the environment, and I blew up the workspace a bit for you. So basically you import your images, the check marks show that they've been successfully referenced with your IMU data. You have the option to group your images into chunks. So you have like chunk 1, chunk 2, which you can choose to merge together later if you want. And so for the Orthomosaic, the general workflow would be you would align your images, and which gives you your tie points, which are these ones. And then you would build the dense point cloud, which you can export on its own and use that to patch small holes in LiDAR data. And then you can build the DEM and finally export, build and then export the Orthomosaic. There's also mesh and texture features which weren't relevant for this project for me, but they're excellent for modeling other projects like wing skulls. But that's totally different. You can batch process them in Photoscan, which is great. So this is a more specific workflow. I chose to include this bounding box stage, because for a while Photoscan would do this thing where you would align it, or if you just batch process the whole thing, after alignment, it would reset the bounding box. And so you could have this giant project that would be like 2,000 images. It would take like 4 days to process, and then you get out, and then you get this. And so this was on purpose, but this here, and this here, and this here wasn't. So when you put that much time into it, you don't want to mess around with that. So that's why I altered my workflow a little. So one of the main challenges of the project was the fact that it couldn't be processed all in one go. So with the 2 different data sets, and each color here is a different flight, I had to figure out the best way of processing them. So I could have processed each of these two separately and like broken them down into chunks and done it that way, but the problem with that is that like how it's so narrow here, it would come out at like 1.5 of the 1 to 2500 scale tiles, and so it made it really messy and time consuming when you're choosing which tiles to take from each set to make a complete tile. So, and the way it would have looked like if I were to do it that way, I have like, this was a hole that I had to patch. This is a chunk of the lower resolution data, and then this would be the higher resolution. So I would have taken 4 or 6 tiles from this one, and as many as I could get of the high resolution, and then filled in the rest with the low res. But it was, yeah, it was just time consuming and not ideal. So instead, I chose to cherry pick my images. I would take, so this is the high resolution, so I would take all of those for the chunk that I wanted to process, and then I would go, and so I would select them, I would export a CSV list, and then I would take this one, I would take all of my lower resolution images, I would manually deselect the ones that overlapped, and then I would export that one, and then I would reference that list, go through and import all my selected images into Photoscan. It sounds time consuming, and I know that someone that is more comfortable with scripting could definitely script something to do that for them, but I had a good sort of system so that I was making sure I didn't make any mistakes, and then I also I had the time while I was waiting for other projects to process. So third option that I didn't really mention was to put one data set in one chunk, and then the second in another chunk, and then merge them together later. And merging chunks, it seems like a good idea. But so if, say I wanted to fill a hole like this, I could process the hole in a separate chunk, and I can merge it, but what it seems to do is it just sort of like bashes it in there. And so what you end up is, it might fill the hole here, but you could end up with like, your power line might not line up, you might have a road out here, and so it's just kind of does more harm than good. And if you look closely at the flight path around this hole, like here, it's all really nice and even, and then you get over the hole, and there's like a second set. And so what seemed to have happened is they'd be flying the images, and then the camera would just miss 1 or 2, and then they would realize and then circle back and take another like little set of images. And I don't know what it was about, but if you know why it does this, let me know. But Photoscan hated that, and because I don't quite understand, because logically to me, if there's the corresponding IMU data, it should be fine. It should just fit. But it didn't. So then usually what I would do is I would take a subset, I would process it completely separately, like 100 to 300 images, and then I would just cut out the good tiles and then add those to my good packets. And then sometimes I couldn't quite get it, in which case I would send it off to Dick, and he would piece in with Photoshop. So the reason I didn't just select all of both sets of high and low resolution images to process together is because it gave a patchier product than manually selecting the exact images that I wanted. And so then it would give sort of patchier bits, like, so there's some nice high resolution stuff in this like lower resolution area. Or a messier one, a little bit, is so you have some like shadows going this way, some shadows going this way, there's a little bit of this one here, and so, but I could do better than that, so I wanted to do better. So yeah, so then there's this great feature in Photoscan where you can delineate a polygon, and then Agisoft will generate a list for you of all the images that fall within that polygon, and then you can manually select or deselect which images you want it to use. So you can take it from a bridge like this, to a bridge like that. So you can clean it up really nice, and you can also do that. So in the forest, you could do that if you really wanted, or as far as I'm aware, I also sort of solved that problem by choosing the high and low sets manually. So, network management. So that was another big benefit to not working in chunks, because I could use separate portions of the project, and I could have them in separate files all at once, so then you can throw them all in the network and they can be processed simultaneously. And so I almost always had my 3 big machines running on the network and set a high priority, especially the monster machines, so that they would pick up jobs first, before the lab machines if they were also on the network. The problem with having the lab machines on the network is that some tasks or some sections of tasks, like in the finalizing stages, they'll only use one machine at a time. And so it sounds useful because then the other machines are free to work on other jobs, but what would happen is then I'd be trying to push one project through to the end so that I could start clipping it, and then a single machine task would end up on the lab machine. And then the big machines would just burn through everything they were doing, the lab machine would be still doing its thing, and then the big machines would just be sitting there waiting for something to do. So pausing projects in the network manager was actually really valuable, because you could pause a project, all the computers that were doing a job at the time would finish what they were doing, it would clear off the network, and then you could resume, and then automatically your higher priority machines would pick up those jobs that you wanted to push through at the time. And then also sometimes the project would get stuck somewhere on the network. So having up to 20 computers on the network at a time, for some reason, some projects, they would just get stuck at 49.4%. And I thought that, oh, something just happened and it failed and I had to force close the project and then resume it wherever it saved last. But I discovered that if you just pause it, you wait for everything to clear, your problem machine won't clear. And then you can follow the IP address, go to the computer, and reset its network connection, and then you just resume and you're good to go. So the last network type challenge was the fact that Agisoft Photoscan and PCI don't really get along. So each of them wants to use as much processing power as they can get their hands on. But then when you try to run them both on the same machine, Photoscan just elbows Geomatic out of the way. PCI just sits there waiting to clip while Agisoft is doing its thing. So whenever I was clipping, I would take thing 1 off of the network so it could do its thing while everything else was processing. I should probably show you some end products. So this is basically the way that I would process them. Is I would select, I would do them in basically a row at a time, sometimes 2. At the end, I did all 4, the top 4 rows in one go. I think that was my biggest file. I'll get there. So yeah, so when I would select the images for an area like this, I would give myself like a buffer zone of like 1 to 2,500 tiles. And so then that way, and then I would go process my ortho and clip it out. And so it's a little bit more like that. And then here's one of the 20,000 scale tiles, and then there's one of the 2,500 scale tiles, and zoomed right in. So, and then my next hurdle, I hope you can read that. It says low disk space. So you understand the significance of this photo in particular. If you look in the background, you can see the shape of this ortho that I was clipping is this one, and I worked from the bottom up. So this was very early on when I started my regular phone calls to Rob asking for more storage space, and then he would make his runs to Costco and clean a lot of hard drives, and that also started my new file management system, which was a spreadsheet where I kept track of what files were on which drive and how much space I had left. So my Agisoft files were regularly in the terabytes, usually 4 to 7 terabytes. each. And then my exported orthos would be in the hundreds of gigabytes, and each 1 to 2500 scale ortho was about a gigabyte in size, and I had 2,136 of them. So this is my collection at the end of summer, which it doesn't actually look as big as it felt, but by the end I was deleting early work to still make room at the end, because I think Rob might have cried if I asked him for more hard drives. So there were 14 drives there, a total of 68 terabytes. So I did a little sum there. So my side of the project, which was not the entire project, so this is like only producing the ortho images, not including the LiDAR, was 173.5 terabytes. So, thank you.